In this video, we'll generate the decaying cosine and the decaying sine using the functions complex, exponent, imaginary real, imaginary, and exponent. We begin with the values of v and w. So v will be data validation, list of items from 1 to 5. This will be 1 to 5. So we can start with 1. Likewise, the value of w. So this will be data validation, list of items from 6 to 15. So we can start with 6. And the data set, starting with the e to the minus vx times cosine wx. So array formula, exponent minus v times x. That's the first part. The second part, cosine wx. So cosine w times x. And enter. So that's the trend line. We continue with using the complex function. So we begin with the complex. So this is equal to complex minus v minus vx minus v times x, comma w times x, and after that we apply the exponent function. So the exponent will be im exponent of the complex value, and then the real part. So we want the real part of this. So this will be IMREAL. And finally, it's an array formula. So array formula, then enter. So the red matches to the blue. So this is the complex form, while this one is the trigonometric form. They're the same. We continue with the sine function. This is equal to array formula. The first part is exponent minus v times x. That's the first part. The second part is sine. So sine w times x. So that's in green. This is the sine, decaying sine. We continue with the complex form, which is we begin with the complex values of complex minus v times x. That's the first part, comma, that's wx. So w times x. Next, we continue with the im exponent. So imaginary exponent. imaginary exponent. Enter. And finally, we want the real part, the imaginary part. So imaginary, that's imaginary. We want the imaginary part. And because we want the whole array, so it will be array formula. Array formula. So the purple one in dots match to the green. So this is the decaying sine. Now we can change the value of, we can change this to 9, then 12, that is increasing the frequency, and 50. There's an error, but that's negligible. That's normal because this is the ordinary least square method, so it's a polynomial. Next, we continue with v equals 2. Start with 6, then w equals 9, then 12, and 15. Then we continue at v equals 3, w equals 6, changes to 9, increase the frequency to 12, and 15. And changes to 4, starting with 6, and 9, then 12, and 15. Then 5, you can start with 6, 9, 12, 15. This completes the use of the complex function, imaginary exponent function, imaginary real, imaginary, and exponent to show the trend line and polynomials of the decaying sine and cosine.